Assalamu alaikum students, welcome to class 10th physics. We were doing unit 14 optics, and today we'll continue the long questions of this unit, and we'll discuss 6 to 10 questions. So let's get started. Question number 6 is analyze the speed of light in material medium. हमने स्पीड ऑफ लाइट को डिस्कस करना है मटेरियल्स में. मीडियम वैक्यूम में तो वी नो, बट मीडियम्स में कैसे मूव करती है स्पीड ऑफ लाइट, वी विल डिस्कस इट. Light is one of the fastest entities in nature. In a vacuum, it travels with its maximum speed of about 3 into 10 power 8 meter per second. However, when light enters material medium such as air, water, glass, its speed decreases. This is due to the interaction of light with atoms of the medium. बेसिकली जो वैक्यूम होता है वो एम्प्टी होता है, ठीक है. उसमें जो लाइट ट्रेवल करती है, लाइट को बीच में कोई रुकावट नहीं होती. दैट्स वाई दैट इज द फास्टेस्ट स्पीड. लेकिन जैसे लाइट किसी मीडियम में एंटर होती है, जैसे एयर हो गई, वाटर हो गया, गिलास हो गया, उसमें उस मीडियम की जो एटम्स होते हैं उनके साथ लाइट का इंटरेक्शन होता है. इस वजह से उसकी जो स्पीड है वो डिक्रीज करती है. व्हाई डज द स्पीड डिक्रीज? व्हेन लाइट एंटर्स अ मीडियम, द इलेक्ट्रोमैग्नेटिक वेव्स disturbs the electrons of the atom. वो जो electromagnetic waves of light हैं वो आकर डिस्टर्ब करती हैं electrons of the atoms को. These electrons absorb energy and then re-emit the wave in the forward direction. ये जो electrons हैं वो उस एनर्जी को absorb कर लेते हैं और फिर उसको re-emit करते हैं wave को in the आगे वाली direction में re-emit करते हैं. Although each absorption and re-emission takes only a very tiny time, the repeated process delays the overall progress of the light. मीन्स वो जो एटम्स होते हैं वो उसकी लाइट को एब्जॉर्ब करते हैं और फिर फर्दर आगे की तरफ फॉरवर्ड री एमिट कर देते हैं, फॉरवर्ड डायरेक्शन, आगे की डायरेक्शन में. ऑल्दो ये टाइनी टाइम्स के लिए हो रहा होता है, बट ये कंटिन्यूस प्रोसेस होता है जिसमें बार बार एक साइकिल चलता रहता है, रिपीट होता रहता है एब्जॉर्प्शन एंड री एमिशन का, जिसमें टाइम लग जाता है, ठीक है. ओवरऑल जो प्रोग्रेस है लाइट की वो कम हो जाती है. एज अ रिजल्ट लाइट अपीयर्स टू ट्रेवल स्लोअर इन अ मीडियम कंपेयर टू द वैक्यूम, जिस वजह से हमें लगता है कि लाइट इन मीडियम्स में स्लो मूव करती है देन वैक्यूम. Refractive index relation. The degree to which light slows down is measured by refractive index of the medium. हमने रिफ्रैक्टिव इंडेक्स वो डिग्री मेजर करनी होती है जिसमें हर एक मीडियम में डिफरेंस आता है इसके स्लोइंग का. For example, it is n is equal to refractive index of that medium is equal to speed of light divided by speed of light in that medium. कंपैरिजन हो जाता है एक तरह से कि मैक्सिमम स्पीड के साथ उसका उस मीडियम में मौजूद स्पीड का क्या डिफरेंस है. अ हायर रिफ्रैक्टिव इंडेक्स मींस ग्रेटर स्लोइंग डाउन ऑफ द लाइट. जो अगर जितना रिफ्रैक्टिव इंडेक्स हाई होगा उतना ही पता चलेगा कि लाइट स्लो डाउन हुई है, ठीक है. एग्जांपल्स ऑफ स्पीड इन मीडिया, like air में क्या है, it is about same as vacuum in 3 into 10 power 8 meter per second. Water में it is 2.25 into 10 power 8 meter per second, and glass में it is 2 into 10 power 8 meter per second. Okay, thus light travels fastest in air and slowest in glass because glass is optically denser. glass denser होता है. अगर हम देखें तो एयर में फास्टेस्ट होता है, फिर उससे वाटर में होता है, देन ग्लास में होता है. कंक्लूजन, द स्पीड ऑफ लाइट इन अ मटेरियल मीडियम इज ऑलवेज लेस देन इन वैक्यूम ड्यू टू एब्जॉर्प्शन एंड री एमिशन ऑफ द एटम्स. द एक्सटेंट ऑफ रिडक्शन डिपेंड्स ऑन द ऑप्टिकल डेंसिटी ऑफ द मीडियम which is measured by refractive index. Okay, question number 7 is what is refractive index? Elaborate your answer. Refractive index होता क्या है और इसको हमें elaborate करना. अभी पीछे ही हम पढ़ के आ रहे हैं कि refractive index of a medium is the measure of how much light slows down and bends when it passes from one medium to another. It is defined as refractive index is equal to speed of light divided by speed of light in that medium. Speed of light in vacuum divided by speed of light in that specific medium. Explanation, light changes its speeds and direction when it enters a medium of different optical density. Okay, refractive index tells us how optically dense a medium is. A higher refractive index means light travels slower, medium is optically denser, for example glass. And lower refractive index means light travels faster, medium is optically rare, means air. एग्जाम्पल्स अगेन एयर में रिफ्रैक्टिव इंडेक्स होता है 1.0003 विच इज ऑलमोस्ट 1 ओके और वाटर में क्या है 1.33 है और गिलास में 1.5 है हायर होता जा रहा है मीन्स वहां पे स्पीड स्लो होती जा रही है दिस मीन्स हाई ट्रेवल फास्टेस्ट लाइट ट्रेवल फास्टेस्ट इन एयर एंड स्लोएस्ट इन गिलास रिलेशन विद रिफ्रैक्टिव इंडेक्स रिफ्रैक्शन इसका रिफ्रैक्शन के साथ क्या रिलेशन है एक स्नेल्स लॉ वी हैव डन इन द चैप्टर refractive index also explain the bending of light at the boundary which is shown by a relation known as n1 sin theta 1 is equal to refractive index 2 sin theta 2. Okay, this law shows that the change in the angle depends on the ratio of the refractive index. Conclusion: refractive index is fundamental optical property that explains why light slows down in dense media, determines how much light bends, and has practical use in lenses, prism, fiber optics, and everyday phenomena like bent straw in water effect, etc. Okay, question number 8 is differentiate total internal reflection from refraction. Also derive a relation for critical angle. हमें टोटल रिफ्लेक्शन और टोटल इंटरनल रिफ्लेक्शन को कंपेयर करना है रिफ्लेक्शन होता है द बाउंसिंग बैक ऑफ लाइट फ्रॉम a surface into the same medium. Total internal reflection का मतलब होता है the complete reflection of light inside a denser medium when it strikes the boundary with a rear medium at an angle greater than the critical angle. Okay, reflection usually happens at the boundary of any surface like mirror, polished medium, metal. Our total refractive index होता है happens only at the boundary between a denser and rear medium. Okay, no special conditions required in reflection occurs whenever light hits a refractive surface. जबकि total internal reflection के केस में two more conditions must met. Light travels from denser to rare medium, and the light angle of incidence must be greater or equal to critical angle. Okay, nature of reflection is it can be partial, some light reflected, some absorbed and transmitted, while nature of TIR is always completely reflected. 100% light reflect back करती है. Example: image in a mirror, polished floors are the example of reflection. जबकि TIR की example है sparkling of diamonds, marriage in deserts, and optical fibers. Okay, derivation of relation for critical angle. Let light travel from a denser medium to a rare medium. ठीक है, दो medium we have used and one एक refractive index and one दूसरे का है and two. According to Snell law, and one sin theta is equal to n2 sin theta. Theta of incidence and theta of refractive index हम देखेंगे. At the critical angle, the angle of reflection is refraction is 90. So हम 90 की वैल्यू पुट करेंगे sin 90 will be equal to 1 और ये हमारे पास आ जाएगा sin c is equal to n2 divided by n1. हम c फाइंड करेंगे sin inverse into n2 divided by n1, where c is the critical angle, n1 is the refractive index of denser medium, and n2 is the refractive index of rare medium. So reflection is general bouncing of light. TIR is specific case with 100% reflection. The critical angle relation helps in designing optical instruments like periscopes, binoculars, and fiber optics. Next question is enlist the uses of fiber optics in telecommunication system. Fiber optics का telecommunication system में क्या uses है? Fiber optics is widely used in modern telecommunication systems due to its high speed, efficiency, and reliability. Some important uses are high speed internet transmission. Fiber optics allow data to be transferred at very high speeds with minimal loss, providing faster internet services. Telephone communication. Video signals are transmitted over long distances through fiber optics cables with clear quality and low distortion. Cable television. Fiber optics delivers multiple TV channels with high resolution and without single interference. Computer networking. Local area networks, LANs and WANs and data centers use fiber optics for fast and reliable communication. Submarine cables. Undersea fiber optic cables are used for international communication, connecting different continents with high capacity data transfer. Satellite communication support. Fiber optics serve as a ground communication link for transmitting signals to and from satellite stations. So, fiber optics play a key role in telecommunication by providing fast, reliable, and long distance communication in internet, telephone, TV broadcasting, networking, and global connectivity. Next question is illustrate the thin lenses. Also explain behavior of converging and diverging lens to parallel beam of light. Thin lens is a lens whose thickness is very small compared to its focal length and radii of curvature of its surfaces. In such lenses, the reflection is considered to occur only at a single plane, making the ray diagram simple and ideal. Thin lenses are of two main types, converging and diverging. Converging means convex and diverging means concave. Converging lens thicker at the middle and thinner at the edges, and जो diverging होते हैं those are thinner at the middle and thicker at the edges. Behavior of converging lens, convex lens. When a parallel beam of light passes through a convex lens, it converges the rays to a single point on the principal axis called the principal focus. Thus, convex lens bring parallel rays to the real focus. Behavior of diverging lens. When parallel beam of light passes through a concave lens, it diverges after refraction. The diverged rays appear to come from a single point to the principal axis on the same side of the lens, called the principal focus. Thus, a concave lens produces a virtual focus. Diagram illustration of thin lenses. Here is the illustration of thin lenses. In left we can see a converging convex lens where parallel rays being bent inward and meet at the focus point. ठीक है. Right side a diverging concave lens where parallel rays bend outward and appear to diverge from the focus. Okay, conclusion. A thin lens is an ideal lens with negligible thickness, and a convex lens converge parallel rays to real focus, while concave lens diverge parallel rays as it coming from a virtual focus. एक ही focus है तो आगे उनको rays को diverge कर देता है. So that's all for today. I hope you understood all the questions very well. If you get any information, any new information from this video, then like it, comment down, share with your friends, and subscribe to this channel for more long questions of this chapter. Till then, Allah Hafiz.